SUE team developed back in 2015. Let me see if I can get my screen to go to the next slide. So this SUE team was actually a little bit more diverse than just SUEs. It consisted of WPC leadership and a couple of RFC representatives from the Lower Mississippi RFC. And we were tasked to work on projects that help improve the situational awareness and IDSS associated with extreme precipitation events. And those include those that fall within the top 1%. So think of events like the Boulder 2013 flood event, or Hurricane Harvey, or even more recently, Hurricane Matthew. So the EPFT is designed to help improve situational awareness by highlighting climatologically significant forecasted rainfall using average recurrence intervals. In this presentation, when we talk about ARIs, we are talking about ARIs of rainfall, which is the average or expected value of periods, which is usually years, between exceedances of a given rainfall duration. Now, keep in mind that rainfall ARIs are not the same as flooding ARIs. So a rainfall ARI of 100 years will not necessarily cause a flood of 100 years. You do need to consider antecedent conditions and topography and things like that in order to get a real assessment of what the flood impact is going to be if a certain rainfall ARI threshold is exceeded. But nevertheless, they can be used as a good proxy to the potential for extreme rainfall related impacts. The most recent and most comprehensive data set that we have to date is called the NOAA Atlas-14. And the ARIs within the NOAA Atlas-14 can be used to compare to both observed and forecasted rainfall. And it helps to measure the rarity of an event, which should be ideal for impact-based decision support services. And to just give a little bit more information on that, many people don't realize that a lot of hydrologic structures and flood retention systems are designed based off of ARIs of rainfall. These are fed into models used by civil engineers that can determine what ARI thresholds these structures can take before they start to break down or overtop. And many higher level emergency managers at state and national levels understand ARIs, the Army Corps of Engineers, dam operators, and folks that are in the urban department of drainage systems in many cities are familiar with ARIs. So if you communicate rainfall in the context of ARIs, these folks can use this information to determine which structures are going to be at risk if these forecasted rainfalls actually come to be. So just to give you a little bit of the limited but important research on ARIs, there hasn't been much, but there are some folks that have found that ARIs are generally better correlated with flash flood reports compared to fixed QPF thresholds alone. And this research came out of Colorado State University from Dr. Russ Schumacher and his student, who's now Dr. Greg Herman. If you take a look at the image on the right, showing all of those panels of the US, the left column shows the QPE exceedance in the top left corner, and below that, the flash flood reports associated with them. And on the right, you have ARI exceedance compared to the flash flood reports that it's captured. So you can see that on a national level, the ARI exceedance thresholds do capture more flash flood reports. The caveat is that these results are very regionally dependent if you look at it at a regional scale. So some regions like the Northern Great Plains, actually they have found that exceedance thresholds of 2.5 inches in 24 hours better corresponds to flash flood reports. So you can get more information on that by taking a look at those papers. I'd be happy to provide that information for you if you email me after the talk. But at a local level, out of LMRFC, they found that the 2-year ARI could be used for a warning threshold. In the 25-year ARI could indicate major flooding. So I encourage those who are interested in studying ARIs and the impacts associated with them to conduct local research on ARIs that are important, because the threshold, it might be different across the United States and across different CWAs. And then the last bit of research came out of State College from one of our former team members, Rich Grum. He did a little assessment of a couple of extreme precipitation events that produced catastrophic flooding, and found that a lot of the lower resolution models, the global models like the GFS, tend to underperform when it came to capturing these extreme events. So if you look at a QPF to ARI ratio, this is the 100-year ARI now, that the QPF to 100-year ARI ratio, when it hits about 70%, you should be in tune to the possibility of a extreme or top 1% occurring. In here, our metric for an extreme event, we're using the 100-year. The most current data set that we have as far as the NOAA Atlas-14 is concerned in AWIPS, well, we have two data sets. We have one that is just the raw NOAA Atlas-14, and then we also have another data set that folks in the Pacific Northwest and Texas can use, because those values are not updated in AWIPS yet, called the NOAA 14 All US V2. So currently across the entire United States, as well as Alaska, they do have ARI data in there. Of course, if you are in Texas or the Pacific Northwest, you have a little bit less data, and your data sets are older. We do have updated Texas values that are available online. We have those grids, but they just have not been baselined in AWIPS yet. So I don't think that there are a lot of central region offices in Texas as far as I know, so you probably don't have to worry about that, but that's just a little side note. So the design for our table is that it is a situational awareness table where we use color coding to highlight the climatologically significant rainfall from a large amount of QPF guidance. Now, this table that you see here was one of our first prototypes. Imagine that you take a QPF grid in GFE, you divide it by the 100-year ARI grid, convert it to a percentage, and the max value in that grid is plunked into one of these boxes in the actual table. And so you can click on any one of these boxes where there are significant values, and you can see the grid of percentages within GFE. And right now within the EPFT, we have a large suite of both high-res and low-res QPF guidance. We have probabilistic information in our table from WPC. So we have the 10th, 50th, and 90th percentile QPF that we added. We have, you can look at your forecast that you have created in terms of how close you're getting to an ARI, or you can also contour it in the context of all ARIs. We have a little function, if you take a look at this little menu that says ARI, QPF contour ARI. Anytime you have a really high value of QPF to ARI, you can run that function and see which areas are being exceeded by which ARI. So that's a pretty nifty tool. And then you can also update the average recurrence interval on the fly. So if you are like our LMRFC, where the 25-year is significant for major impacts, you can always turn down the recurrence interval so you can see which models are exceeding the 24-year or the 25-year ARI, for example. Besides for the EPFT, we have a few more tools on the VLab. Some forecasters like to use the ARIS. This is a great tool to use if you're in a smaller CWA, because it does take longer to run, because instead of comparing all QPF grids to just one ARI, now you're comparing it to 10 ARIs. It's very easy to identify the max ARI within this table, because that's exactly what it shows. But just keep that in mind, that if you are in a larger CWA and you use this tool, it is going to run slower. And then also to complement the EPFT, we have the EPAT, the Extreme Precipitation Assessment Table, which compares observed precipitation, or QPE, to average recurrence intervals to tell you when an observed storm had exceeded some climatologically significant threshold. So now I'm just going to go through a few cases. One is an experimental use case, and one is an operational use case that I collected over the last few years. And the experimental use case is from Hurricane Harvey. Now notice that we have this key in the top right of this panel that we designed as a loose key for forecasters to be able to identify significant values in the table according to some of the research that we got from Rich Grum out of State College, and also out of some of the research that Russ Schumacher and Greg Herman has done. So these three tables that you're looking at right now, keep in mind the majority of the rain from Hurricane Harvey fell from August 25th through August 29th. On the afternoon of August 25th, I ran the EPFT, and I ran it every day for 3 days to see how well it did in capturing the extremity of Hurricane Harvey. And I want to mention before it's too late that the EPFT itself, the performance of it depends on the model QPF going into it. So if you have bad QPF, you're not going to have good values in the EPFT. Here, we're just assessing it as a situational awareness table. Does it highlight the extremity of the event? And can this be used to enhance your SA and IDSS? Well, in this particular case, I think that the EPFT did do a good job at highlighting the extreme nature of Hurricane Harvey, just from a first glance of looking at these three tables. Now I'm going to show you some images that were collected from these tables in comparison to the QPE. So from the first day, from when I ran it on August 25th, we have 3 grids from the NAM. And if you look at the observed, which is the 24-hour stage for QPE over the same time period, the NAM definitely captured values exceeding 150%, and observed values had exceeded 150%. The NAM might not have captured an unprecedented rainfall because the max value for day 1 actually exceeded 256%. And those type of rainfall values have never been observed in our record. So I'm not going to give it too much flack for that, but what you can see here is that for 3 days, there is some indication, never mind the placement of the rainfall, that an extreme event could manifest from this landfalling tropical system. From the second day that I ran the EPFT, the NAM was still showing results, at least for day 1 and day 2, that the event was going to maintain the extreme rainfall values that were actually observed. The GFS had a little bit of a harder time, which is expected because we know from many studies done on this type of thing that the GFS and other global models have a hard time capturing the extremity of the event, but nevertheless, there are some signals in the GFS where you can see that the rainfall was forecasted to be at least a 100-year event, if not higher. And then finally, for day 1, the NAM did capture, again, for the 28th of August, the extremity of the event. And finally, for day 2, the GFS was catching up as well. So just the point from all of this is that, yes, the EPFD did pick up on the extreme nature of Hurricane Harvey. They are consistent with other studies that have explored QPF and capturing 100-year events. And it does kind of drive home that if forecasters are looking at ratios greater than 75% of the 100-year ARI, they should be tuned into the possibility of an extreme event. And with ratios that are greater than 150%, especially if you have multiple models, they should be prepared for the possibility of a catastrophic extreme rainfall related high impact event, because these values are rarely ever observed. So to put that into practice, we did have a day in 2017 in May. I work out of the Boulder Weather Forecast Office, and the forecasters had a good event to run the EPFT to assess whether or not it would help them with their situational awareness and IDSS. So on the left-hand side of the screen, you see the EPFT. On the right-hand side, you see the ARIS. And the one thing that we can see right away is that 6 models in the EPFT forecasted 24-hour amounts that were at least 75% of the 100-year ARI. So that already tuned them in to this event being a little bit more climatologically significant than what they might have otherwise expected. All guidance forecasted in this tool is greater than 60% of the 100-year ARI. So that gives them the confidence that with all these models agreeing on the climatological significance of this rainfall, that they had a pretty good idea that this was going to be a heavy precip event. The question is, because this was a late season snowstorm or snow rainstorm, were the impacts going to be snow related or heavy rainfall related? So let's take a look at some of the results that came out of the EPFT. Now remember, this is the fraction of the QPF to the 100-year ARI, and the interesting models came from, or the interesting results came from the CMC, GFS, and CONSHORT. And the funny thing is those forecasters look at the CONSHORT and they just nixed that right away. I believe one forecaster yelled, "Whoop, Boulder 2013 flood," because it was just so outrageous. So if you see outliers in the EPFT, you know that you can probably throw them away. However, with the CMC and the GFS kind of agreeing on the extremity of the rainfall, it did kind of perk up their interest to that this could potentially be a heavier event than they're expecting. But then they ran the ARIT. The ARIT over their CWA was a really good tool to use because they could actually see which ARIs were being exceeded where. And this was a day where the models did actually a pretty dang good job of setting up the placement of the precipitation along the Front Range. They had pretty good agreement. And so at the end of the day, although they agreed that it was probably going to be a more snow impact event, they did come to the determination that it was probably going to be closer to a 10-year ARI event, and that the impacts that they could expect would be more along the lines of power lines down or broken tree branches from heavy snow. If there was going to be any rain associated with this, it was still going to be heavy rain, but it was going to be more along the plains in eastern Colorado. They probably wouldn't have to worry about anything more than minor flooding, maybe some minor road flooding. And they did issue a hydrologic outlook for this day. But more than anything, their message was heavy precipitation and impacts from heavy snow. And so graduation ceremonies were able to be postponed. They were able to help those afternoon commuters when they were coming home to maybe get home earlier before this heavy snow really hit. So this is just one of the ways that they use the EPFT to kind of reinforce confidence in the message. So at the bottom of the screen, we have the EPAT that shows 5 observing sources that come into our Boulder office. And 3 of them did indicate that we were over 50% of the 100-year ARI. And this shows here in the observed, this is not a percentage, this is the actual ARI exceedance. This event turned out to be a 25-year ARI event. So now these forecasters can take this information, and the next time they run this tool, if they start to see these kind of results again out of the tool, then they can have a sense of what kind of impacts they could expect. So key points, just to wrap up. NWS forecasters can use the EPF to quickly identify significant precip signals out to 10 days. And depending on how much guidance you have coming into your office, you have a large database of guidance. I know that some offices have overlaid this information with burn scars and low water crossings to be able to highlight higher risk areas. And more than anything, if you're using this terminology with core partners who are familiar with ARIs, it helps to communicate event extremity. And then finally, for those that use the EPAT, I like how some forecasters have used the information to help inform urban flood control district managers on whether a flooded structure was due to the extreme nature of the rainfall or due to poor drainage. So that's just a very powerful aspect of ARIs in general. But we provide this tool to help you put the QPF in the context of the ARIs. We are going to be further developing a web-based version of the EPFT. And right now, as it stands, we only have the GFS and the ECMWF along with their ensemble means from the ensemble data, as well as the NBM. We're going to be improving this tool by adding more recurrence intervals. I would like to get more higher res guidance in there, and the updated Atlas-14 with Texas data in there. So keep your eyes on that. I do have a link at the end of this presentation where you can access this table. And then right now, we also have the Extreme Precipitation Monitor through WPC's webpage. As we start getting into the more rainy season in spring and summer, you can go to this webpage and you can see what WPC's QPF looks like recast in the context of average recurrence intervals. So we have days 1 through 3 on here, the 6 and the 24-hour amounts, and eventually we will be adding 72-hour ARI durations as well as the 90th percentile QPF comparison, so you can get an idea of what the worst case scenario climatological significance of forecasted rainfall is. And we did work with Jill Hardy at WDTD to develop some ARI training. And along with that, I put together a little training module on the EPFT that you can also access from the CLC. And this last slide just shows you the B-Lab web pages where you can download the ARI installation package and the EPFT, ARID, and EPET tools to install in AWIPS. But if you want to go today and check out the global EPFT and Extreme Precip Monitor, here are the links below. You do have to have a NOAA.gov account to access the global EPFT. But as long as you have that, you can view the results, and definitely email me with any feedback or questions if you'd like. But with that, I'm done. Thank you.